Hi, everyone, and thanks for joining this HashiTalk about Vault. For those who have been operating with HashiCorp's open source version of Vault, you'll know that there's a wide selection of storage backends you can choose to store your encrypted Vault data. However, as your secrets management practices mature or the needs of the business require that Vault scales, meet certain business continuity requirements, or follow certain compliance standards, it can feel a little bit disorienting to find your way around Vault's documentation and learn guides to try and piece together a path or approach to enable the enterprise feature sets of Vault and bring your secrets along in the process. So my goal for today's HashiTalk is to explain and demonstrate one path to do this to show that it is possible. There are many roads, if you will, that can take you from A to B. So consider this one way to accomplish this migration task with a demo that goes to prove as such. This talk might sound familiar because I gave a similar one over a year ago. And while I knew it was possible with my own testing and helping customers make that transition, that talk was admittedly abstract, mainly because there were so many variables. So for this talk, I decided to box this HashiTalk into one approach and then demonstrate that path. Just keep in mind that in 30 minutes, I'm trying to find the balance between detail to show how it works and keeping it abstract enough to fit within the time given. With that, I welcome you to my HashiTalk for 2022. My name is Nick Young, and I have the privilege of serving as a solutions engineer at HashiCorp, covering our globals accounts in the Western United States region. I use the freeway analogy to start my talk because I live in Southern California. So naturally, freeways and directional confusion are just kind of a way of life here. Today, I have 5 areas of focus I'd like to cover. First, I'll give you an overview of my setup for this demonstration. Second, I'll discuss the preparation and the planning for the tasks at hand, so it gives you something to think about as well. Third, we're going to walk through the approach using visuals I have in slides here. And then I'll guide us through a demo to execute that planned approach. And finally, I'll close out by sharing the docs, the guides, the learn pages that I found most useful when thinking about this subject. Just a couple things to keep in mind about this particular topic. First and foremost, while this talk shows that it is realistically possible, it does take time, research, and a very solid understanding of Vault. So if you decide to make that migration, you may do so at your own risk, as this talk isn't a substitute for professional services. On that note, consider hiring help if Vault underpins critical production services, so that that partner or that service company can help you plan based on your unique situation. While the open source Vault binaries that HashiCorp publishes are the same, everyone's environment is unique with a web of dependencies. Next, I would also consider the consolidation of multiple open source clusters into one not in scope for this HashiTalk. As a matter of fact, if that many-to-one consolidation is your goal, then you'll definitely want to hire professional help with the data migration, since you'll need to do this manually or build some sort of custom tooling. And then lastly, I just wanted to make it clear that it's a great thing to have your choice of Vault storage backends. I think the last time I counted, there were 23 or so. However, when you make the move to Vault Enterprise, you're given the choice of either integrated storage using Raft or Consul, both of which are developed and maintained by HashiCorp. While you can use integrated storage or Consul in open source as one of those many options, in Vault Enterprise, these are really your only 2 options so that HashiCorp can best support you, and so you can leverage some of the replication features of the enterprise capabilities. So with that, let's talk through the environment setup. I work at HashiCorp, so naturally I use Terraform and the AWS provider to provision 3 separate Vault nodes running on separate EC2 instances. So imagine that each one of these white boxes as separate Vault clusters with 1 Vault node in each. For each cluster, I'll label them using OSS for open source, ENT referring to Vault Enterprise, and HSM referring to Vault Enterprise with the HSM integration. This way, for all of you viewers, you can sort of follow along, especially when I get to the demo. The first Vault cluster runs the open source binary and is backed by DynamoDB. And I chose this for the demo because it's a backend I often find with Vault practitioners who operate in AWS. This is my current state since it holds all of my Vault data, including auth methods, policies, various secrets and secret engines, and I'll explain a little more on that shortly. Then I have a second node running the Vault Enterprise binary, which is different from the open source binary. Here we are using integrated storage where the data resides encrypted on the local file system. This is what we will first migrate the data to from our open source Vault. And I chose integrated storage because it is simpler to operate over Consul. And integrated storage is what Vault clusters use in HCP, which is our HashiCorp cloud platform. If you don't need the HSM integration, you could stop at this stage and call it a day. But in this demo, this is really a sort of temporary state to get us towards Vault Enterprise, where a cloud HSM auto unseals our Vault. And that brings us to this cluster, where we have a version of the Vault binary that includes the enterprise capabilities, as well as the integration with an HSM represented by that orange lock and key symbol. Just a point of emphasis, the 3 Vault servers you see in this demo are all running 3 different versions of the Vault binary. So there's a version for open source, there's one for enterprise, and there's one for enterprise with HSM integration. If you take nothing away from this HashiTalk, I think planning is crucial here. So I'll outline a couple of the things that I'm planning for prior to the execution. First, we'll want to take an inventory of our open source Vault cluster, first by knowing what our unseal and our recovery keys are, because obviously we're going to need those. Hopefully you have that stored safely somewhere. And in this demo, we're going to use the root token, but we're also going to leverage the user pass authentication method to test that our ACL policies and auth methods are being migrated as well. Speaking of policies, knowing your auth methods is going to be important because users and machines will want to authenticate to Vault as they did before the migration. And if you have all of this using Terraform and it's all configured with sort of Vault administration as code, then congratulations, you have sort of a known good state of your Vault configuration and version control. Next, consider the stored secrets and the various secrets engines. For this demo, I'm using a variety of examples, including key value, transit, which is leveraged for encryption and decryption as a service, PKI for issuing certificates, and the database secret engine for a MySQL database running in AWS. Finally, we'll want some steps to validate that Vault responds to certain requests as we expect. So we'll want to ensure that it can retrieve stored key values, decrypt some ciphertext, issue client certificates, maintain Vault leases, and generate new database credentials. This will be critical so that we know all of our data is kept intact throughout the migration process. Let's also forget not to back up the storage backend that we're using so that we have a known good point in time snapshot of our Vault data. For DynamoDB, we can either back up the table or replicate the table after stopping the Vault service. If I want to be certain I can roll back, I would restore the storage backend to some completely separate Vault node and test to make sure everything works as expected, but I won't be doing that for this demo. And now we're going to talk through the approach just to help you visualize the workflow before I show the demo. We'll focus on our OSS Vault shown here. And first, we're going to log into this Vault and run a series of tests to validate that I'm getting the responses out of Vault that I expect. This is where all of my auth methods, policies, secret engines are set up. So I want to make sure that everything is validated and tested prior to the migration. Then we're going to stop the Vault service so we can ensure consistency of the data with no new leases or secrets being generated. And then we'll also want to take a backup of our Dynamo table at this point. And then we're going to log into our Vault Enterprise node and issue the Vault operator migrate command while passing in a configuration. One thing to note here is that mentioned in this command's documentation is that the destination Vault node should not be initialized, since doing so would create its own unseal keys, root token, etc. So as part of this migration command, it's actually going to initialize the Vault node before copying our data over. The configuration that we're going to use as part of the migrate command comes in the form of an HCL file, which is going to look something like this. Here, the storage source, which contains my Vault data, is DynamoDB, and the storage destination is going to be Raft or integrated storage. Once the migration is complete, I can use the same unseal keys from my open source Vault to unseal the Vault Enterprise node. From here, I'll want to test and validate that I can do things like read key values and interact with the secret engines that I originally configured. Once my testing and validation is complete, I'll then look to transition to another Vault Enterprise cluster, except that this Vault cluster is integrated with an HSM, and the Vault node is running the Vault Enterprise with HSM binary, which is different from the open source and the enterprise binaries. I have deployed a Cloud HSM in AWS, which will be used for auto unsealing Vault. To make this transition, I'm going to configure my enterprise node as the disaster recovery primary cluster. And then I'll configure the Vault HSM node as the DR secondary. And once that's completed, my Vault data will be reliably replicated from left to right, as shown here. And I'll actually add some additional data, key value data right at this point, just to show that the replication is happening in near real time, and we'll test this at the very end. And then I'll disable replication on the DR primary. And then I'll essentially fail over to the DR secondary by going through a promotion ceremony. Doing so will enable this Vault with HSM environment to become the new primary and the active Vault cluster that can respond to Vault requests. And finally, to ensure all of my Vault data flowed properly through this journey, I'll run the same tests as before to validate my secrets and secret engines are as they should be. All right, so finally, we're here for the action and we'll get into the demo. All right, so here I have three distinct terminal windows. Starting on the bottom, I have an SSH session to my Vault open source environment shown by this dark gray window. On the top left, I have my session to the Vault enterprise environment in that green window. On top right, I have my session to the Vault enterprise with HSM environment in that orange colored window. This should hopefully help you follow along mentally with the diagrams that I was showing earlier. I'm going to first start on the bottom terminal with my open source Vault, which contains all of my secrets, auth methods, policies, and so on. And first, I'll just want to check the status of Vault by running a Vault status. This shows that Vault is using Shamir as the seal type. It's initialized and unsealed, and it's using DynamoDB as its storage type. So I know I'm sort of in the right place. Next, I'm going to list out some of the files that I'll be using throughout this demo. First, the ciphertext file is something that I generated when I was encrypting some plain text using the transit secret engine. I'm simply just using this file to ensure that I can decrypt that text throughout this migration process. The lease ID text file just captures a lease generated by Vault when I created a MySecret credential using the database secret engine. And I just want to make sure leases are sort of being transferred again throughout this migration process. The output text file was created with some outputs from the Terraform run just to help me automate some of the demo. The test script is something I'm going to show in a minute. And then that Vault init JSON file has one key share and the root token that were generated with this Vault when I first initialized it. And again, the reason for the file is just to help sort of automate some of the demo. So first, we're going to check out the test script that goes through testing the secret engines and will be a form of validation as I progress through the migration. So if I look at test Vault, you'll see that first I'm logging in with the root token, and then I'm basically using some colored echo commands and some sleep commands to sort of automate all of the Vault commands and validation steps to tell me that I'm getting the responses I want out of Vault. The goal for the sleep commands is just to make sure that the terminal isn't printing too fast, right? And then we also test the user pass auth method with a policy to ensure that policies are being transferred in the migration process as well. So with that, that all looks good. I'm going to go ahead and issue that test. And then we'll see here that slowly but surely, we're sort of going through all of the steps that I've sort of prepared to ensure that, one, I can extract key values. I'm taking something like ciphertext, and I'm able to convert that back to plain text. And I'm just printing that again as an echo command in the terminal. I'm also making sure that I can generate certificates with the PKI secret engine. I wanted to make sure that, that I have a certain lease that I'm tracking, and I want to make sure that lease is sort of being carried throughout the migration process. I'm also generating an additional dynamic database credential just to show that it works. And then I want to make sure my policies and auth methods are coming along with me in the process. And it's more than just being able to read out key values, but I also need to make sure that all of the controls that I've established in Vault's ACL system are working. So I also want to make sure that I'm denied secrets on certain paths as well. All right, so all that looks as we'd expect. And next, we're going to go ahead and start the migration process by stopping our Vault service. This way, we know that there's no additional data or leases being created in Vault. So we'll issue a sudo system CTL stop Vault. And then at this point, the next thing we'll want to do is take a backup of our storage backend. This process will look a little different depending on your backend, but because I'm using Dynamo for this demo, I'll follow the backup process as outlined in AWS's documentation. So in this command, I am both creating a backup and then I'm storing the resulting ARN as an environment variable called backup_arn. And here I'm just a little side note, I'm using a tool called JQ just to filter JSON and just pull the ARN that I need. And then with that environment variable, I'm going to want to check that the status of the backup is complete. So in running this command, I see that the status is available, which tells me that the backup was successful. All right. So next, I'm going to go ahead and close the gray window because we're not going to need that anymore for the remainder of this talk. Now we're going to focus on the environment with Vault Enterprise here on the left-hand side in a green window. And the right-hand side is the SSH session, again, to our Vault with HSM cluster. Just a reminder about the Vault Enterprise node, it's been set up with the Vault service loaded, so it has not been started or initialized because this next step will initialize and copy the data for us for Vault as part of that Vault operator migrate command. So first, we're going to take a look at the HCL file that we'll need as part of this migration step. So I created migrate.hcl, and we see, again, our storage source is DynamoDB, and our storage destination is Raft, or integrated storage. As I showed in the deck, this Vault Enterprise node will need access to that Dynamo database table, just so that I can copy that data over. And the way I'm doing that is through instance profiles. That way I don't have to pass credentials into the configuration here. So with that, we're going to back out of this and check the migrate data script here. And this should migrate script. Oh, migrate data. There we go. And here we're going to notice 4 distinct commands. First, we're going to run that Vault operator migrate command, passing in that HCL file that I just showed. And then we're going to change ownership for the Vault service to access this directory, which is where we're going to sort of store all of our Vault data. And then we're going to start the Vault service. And finally, we're going to check the status. So we'll run the operator, we'll run the migrate data script here. All right, so at this point, it's looking at the uninitialized node. It's electing a leader, which is going to be itself. And then it goes through the process of copying all the data. And then we're doing everything else that I called out in the script. Next, as we have to do whenever a Vault service first comes up or restarts, we need to unseal Vault Enterprise. And we're going to do that using the original unseal keys we used from our open source Vault. So if you want to see what that looks like, I just create another script. We're just doing the Vault operator unseal command, and I'm passing in that single key share, waiting for a few seconds, and then checking the status of Vault. So let's go ahead and run that. All right, so as we're sort of waiting here, we see that the HA mode is active at the moment, but if we wait for a little bit and then run Vault status again, we'll see that this node has elected itself as the active Vault node. All right, and now we see also that we're on Vault Enterprise, which is what we'd expect. As much as I trust the migration tool, it's also, again, just important to validate. And so I'm going to run that same test script we used earlier on the open source Vault to ensure that I'm getting the proper responses. I use a different name for the script, but the tests are very much the same. So here I'm going to run test Vault ENT. And again, it's going to log in with the root token, and it's going to go through all those tests. If you'll notice, I just changed the color of the echo commands just to sort of show that we're in a different space. But the commands, by and large, are all the same. I simply just changed it. I just changed the colors. So we're able to generate a certificate. We're able to decrypt ciphertext. I still want to make sure the leases that I had from the beginning are there to begin with. I still want to make sure that if I'm going to generate new credentials, that still works. And then finally, I'll also want to make sure that my policies came along in that migration process. And then I'm using the user pass off method to log in using my username and password with a very specific set of policies. And with that policies, I should be able to access certain key values, and I should also be denied the ability to access other key values. So this is great. Everything on the Vault Enterprise cluster is working as we'd expect. All right, so the good news here is we've made it this far, testing's complete, and now we're gonna go to that next step of setting up disaster recovery replication. Here you'll notice me kind of jump between the green and the orange windows to represent the enterprise and the HSM terminal sessions. So I'll do my best to call it out so that you all can follow along. First, what we're gonna do is we're gonna log in with our root token. And for brevity, I'm gonna start sort of pasting in commands at this point. And this is a good sign because now our root token that we used in open source still works with our Vault Enterprise cluster. And then we're going to enable the Vault Enterprise cluster as the DR primary. And then from there, we're gonna have to generate a DR token, which we will save to a text file. So I run this command and then I'm passing it into primary dr token.txt. And then I'm basically gonna take this value and copy it over to the HSM integrated vault using SCP, right? And now we're gonna jump over to the HSM terminal session here in orange. And first, again, we'll just wanna sort of check the state of our vault cluster. So if I run a vault status, we're gonna see here that there's something called a recovery seal type that's Shamir. Because now that we're using a cloud HSM as our auto unseal mechanism, we also see that it's not using Shamir as the seal type. So this is what we would expect when we have something auto unsealing our vault. We also see that the version is using 193 enterprise.hsm, which just means that we're enabling that HSM functionality, and we're also using Raft as the storage type. Next, we're going to take a look at the Vault server configuration here, just to show you what it looks like when we're configuring Vault with HSM integration. And here you'll see a lot of these parameters should look familiar, things like UI true, the API address, cluster address, the listener. But I just want to draw your attention to the seal stanza right here, which just demonstrates that we're using an HSM to unseal our vault. If you want to know how to set up an HSM in AWS, they have very good documentation for that. All right. So at this point, we're going to enable the Vault with HSM environment as the DR secondary cluster using that token that we saved as a text file earlier, and I just copied over. So here, again, I'm basically just catting out that primary DR token text file, and I'm passing that in as the token for this particular Vault write command. And then we're going to check the replication state here. And this just lets us know, are the two clusters in sync? And in doing so, we're looking for stream walls, and wall, WALS, stands for write ahead logs. This is the type of value that we would expect from the DR primary to show that there's consistent and healthy replication. And then jumping back to the enterprise session, we're going to check the replication state on this as well. However, the value that we're looking for is running, which is what we do want for the DR primary. To ensure that replication is functioning, we're going to write some additional key value data so that we can test for this towards the end of the demo. So I'm just going to put a key value here that the key is message and the value is HashiTalk's demo complete. So that should be kind of fun when we look at that at the end of the demo. And then I'll just want to test to validate that I can also retrieve that key value. So this looks good. We're just going to be double checking here, just checking that the replication state here is running, which is what we're expecting. And then jumping back to the HSM enable vault cluster, we want to check that it's still in the state of stream walls. So all of this looks good and it's right where we expect. So we have replication set up. We wrote some additional key value data, which we're going to test for at the end. And it's at this point that we're going to go through a failover process. For this, I'll be leveraging a lot of environment variables and embedding them within commands. So just to help the steps and the automation of the demo, but also this demonstrates the possibilities of automating or scripting this procedure if you so choose. So first, we're going to jump over to the, we're going to stay in the HSM terminal, and we're going to generate a one-time password and save that as a DR OTP variable. So it's going to look something like this. And then we're going to pass that DR OTP value into the nonce variable to initialize and generate the DR operation token. And then at this point, we want to make sure that the DR process is started by using this curl command. And what we're looking for is the key called started and the value equals true. And then next, we're going to save our only unseal key as a variable called primary unseal key. And we're going to save it there. And then we're going to use that along with that nonce value that we set earlier and save this value as the encoded token variable. And finally, we'll pass both the encoded token and the DR OTP values and save that as another variable called DR operation token. All right. So at this point, we're one command away from promoting the DR secondary or the vault with the HSM to become the new primary active vault cluster. But before doing that, we're going to navigate back to the enterprise, the green session here, and I'll just check to make sure that this cluster's mode is primary. And here we see, if we look for the key mode, primary is what we would expect. And now we're going to disable replication on that Vault Enterprise node. And then we're going to check again for the cluster mode. And instead of that mode being primary, now we're looking for this mode, which is disabled. So this is exactly what we want. This is what we would expect. With the DR primary now disabled, we're going to jump back to the HSM session. And then we're going to validate that replication is now broken. So when I issue this command, what we're looking for is connection status is disconnected. In other words, it's disconnected from the DR primary, which is what we want for the failover. And now we're going to go and promote the Vault with HSM from its secondary role to become the new primary and pass in that DR operation token that we built up and saved earlier. All right. And now we're going to check the replication status. And this is what we're looking for. Now the Vault with HSM is now the primary Vault cluster. And finally, to sort of finish off on the test here, we're going to log in using the original root token that we've carried over from our open source Vault. So that's a good sign. We logged in with our root token. And now that final step is to walk through all of those validation steps, which is just like the test that I showed throughout the demo, except that I added an additional Vault KV get command to see if that key value I added during replication came over to this Vault HSM cluster. All right, so as it goes through this test, again, it'll look the same. Again, it's very much the same test script, except that I changed the color of the echo commands again. And I also added one final KV get at the very end of the demo. So this is all good news. I'm able to retrieve key values that I expect. I'm able to take my ciphertext in a file and decrypt that back to plain text. I can generate certificates, and I can see the status of my leases. And you'll notice that that TTL at the bottom there is starting to dwindle, which is what I would expect. I do want the timer to go down. I can still issue new credentials for that MySQL database running in AWS. This is good news that my policies came over. And now I'm logging in using the user path authentication method to just validate that my robust Vault ACL system is very much intact. So getting a permission denied where I should be. And then finally, just wanting to sort of end the demo with showing that the demo is complete and being able to read that last key value shows that replication is happening in near real time. So this all looks good. And we can see that with that final command, we've completed the demo, and we'll jump back to the slides to sort of close out. All right. So now that we've sort of seen the possibilities, I'll re-echo that there's a lot of planning that goes into this. In fact, I just wanted to leave you all with various Vault docs, learn guides, and a repo, especially, that helped me with the setup and the automation of today's demo. That last link in the bottom was particularly helpful to script out that disaster recovery failover process. In closing, I hope you found this one migration approach helpful. If you are considering making the move to Vault Enterprise, obviously the operator migrate command was a key piece in this approach. And while you could do in-place upgrades or change seal types, we find that leveraging DR replication is a safe way to fail over or revert back if needed. Thank you all for joining my HashiTalk, and please enjoy the rest of the event. Thanks all.